All right. Hello, everybody, and welcome back. Let's go ahead and share the screen. And can everybody see the picture of the shield bot?
I have you spotlighted.
Okay.
Getting thumbs up.
Okay. And very quickly, I'm going to unshare and reshare in hopes that, okay. I am not seeing the attendees, participants. Normally,
I've removed the spotlight.
well, yeah, I managed to click something and I disappeared my attendee view, and unfortunately with that it makes it kind of difficult to see the thumbs up reaction, so bear with me a second while I find where I can see, where I can bring back the picture of the attendees. Well, I think I'm just going to have to fly blind, or maybe Stephanie, you can give me counts of thumbs up.
Sure.
Okay, thank you. I appreciate that. All right, well, okay. Sorry about the delay there, everyone, and welcome back to day 3 of the BOE Shield Bot for Arduino workshop. I will go ahead and chat you the link to the slideshow, which again will have a lot of useful well, this is interesting. I've also lost my ability to paste chats in.
Would you like me to remake you host?
I'm almost afraid to do that given how much functionality I've lost. Let's try it.
One moment.
Okay, wait, no, I got it now.
Okay.
Okay, so at least I can paste messages, though I still can't see everyone. Okay, so just a reminder to click view and exit full screen with the Zoom presentation so that you can, if you only have one screen at any rate, go back and forth between, say, your Arduino IDE and the Zoom window. And then, you know, it's nice to have them set side by side. Today, we'll be looking a little bit closer at the book, and I'm going to paste in the that is not a correct link. Let's see here, the PDF book download. There you go. And so with that, you can download the full color vector graphics version of the printed textbook. That's really nice. It's one of the things we use in some of the to make some of the diagrams really large and clear in screen captures for slideshows. I'll mention that later. So just a quick review. We started out with navigation. And so just remember that forward would be if you imagine sitting on top of the breadboard, looking this way, and that that makes this your left wheel, this your right wheel, and accordingly left turn, right turn, forward and backward. And that in order to make the robot roll forward, since the wheels are facing away from each other, they have to be turning in opposite directions. I did point out that there's a measure the distance activity, so students can use distance equals speed times time calculations. And there are also ways to control the speed of the robot. And there also is an activity in which we control the speed of wheels independently, so that if the robot is curving to one direction or another, you can slow down the faster wheel to match them up and get straightforward translation or motion, I should say. We talked about functions. So we had a forward, turn left, turn right, backward, and disable servos function, which I hadn't pointed out before. And so this is one way to set up functions so that in your main code, you can just say forward and a time, turn left and a time. Another approach is to have a maneuver function. And with that, we can actually forget about the fact that the wheels are turning in opposite directions and call the maneuver function and give it 200, 200 for top speed forward, in this case, for a whole 2 seconds. And right here is where the speed of the right wheel is reversed from the speed of the left wheel. So you, and your students don't have to do that in your code, which actually these functions take care of as well, just in a different way. I also just briefly touched on navigation with arrays, and this is where you can put lists of wheel speeds for the left wheel, the right wheel, and then maneuver times into arrays, which are lists of values enclosed in curly braces. And then there is indexing that can be used to grab elements of the array, and this is an important computer science curricular checkbox. We also talked about circuits only briefly. In the book, there's a lot more attention given to circuits. To get to some of the more challenging parts, I went ahead and skipped the circuits, but I will talk just briefly about that now. And that was page 49 and 52. So if I go to page 49, so before building any circuits, just wanted to assure you, since I dove in and showed you how to build circuits, there is an activity where the students learn how to build circuits, and it starts with, hey, here's a resistor. It's a thing that resists the flow of current. It has a value in ohms, and it has little color-coded stripes that are able to tell you its value. And here is how to decode the value of a given resistor. And so in this case, yellow, violet, brown for the color code is 4, 7, and then 1. And basically this last digit, the 1, is the number of zeros to add. So we take the number 4 and 7 and then add a 0, and voila, we have 470 ohms. It also introduces the LED before plugging it in. That's a light emitting diode, and basically it has a longer and a shorter leg to indicate its polarity, and that happens to correspond to its schematic symbol. And we also talk about the relationship between schematic symbols and their respective parts. Then we go into the rule of rows of 5 on the breadboard and also connections around the edge, and how the connections along the left side, these digital connections, and also these analog connections in the lower right, are connected to pins in the microcontroller that's in the Arduino. I see a question that says, when plugging in a resistor, is it directional? And the answer to that is no. And so what we do is we talk about, okay, a resistor simply resists the flow of current. It's in here. I can't exactly, direct you to the specific paragraph without pausing for a bit. But what we say is that, this just resists the flow of current, whereas the LED, the light emitting diode, is a directional part, where if you plug it in backwards, it just prevents the flow of current. If you plug it in forwards, current can flow through it, and it gives off light when that happens. All right. And so then we build circuits with lights on them and talk about how current flows through a circuit, and then run a sketch that turns the light on and off, and talk about how the sketch causes the Arduino to internally do switching between 5 volts to make the light come on, applied to the pin 13, and 0 volts to make the light stay off, because there's no voltage, because 0 volts is also at the other end at ground. So ground on one end, ground on the other. Same electrical potential on both sides, no electrical pressure, no flow of electrons, no current. And then when it switches this to 5 volts, there's 5 volts here, 0 volts there. So there's electrical pressure across this circuit. And so long as you have the LED plugged in the way we want to have it plugged in, current will flow through it and it will give off light. We also talked about timing diagrams. And then what this is leading up to is a little ways ahead, when we talk about the signals to the servos. Let me see if I can find that page quickly for you. Here's an example of a signal to the servo. And instead of taking, a human amount of time, the signals to the servos only make the light go on very briefly and are repeated so rapidly that the eye cannot discern it. It's a persistence of vision thing. So instead of seeing it flickering, it just appears to be dimly lit. And so here again is excerpts from the textbook talking about the switching and how it relates to the code. And then jumping forward to the whiskers chapter, again, we talked about how the whisker, when it's not touching those 3 pin posts, 5 volts is applied to the Arduino pin. And so it returns a 1 when you use the digital read function. And then if the whisker is pressed, the IO pin sees 0 volts. And for those interested in the electric current properties, a little bit of current flows this way at the same time. And also this kind of thing is explained. This is called a pull-up resistor, and either a pull-up or pull-down resistor are required in circuits that measure contact like this, because if you simply made contact, when you make contact, sure, the pin might see ground. The pin might see ground, but if you opened the contact and there was no resistor here to basically supply 5 volts so that it forces it to a 1 state, what happens is, if you don't have that resistor, that large resistor connected to 5 volts, this IO pin and the resistor connected to it become an antenna. And then the 1 or 0 state is pretty much at the whim of, somebody walking by with a sweater that has static electricity on it, which happened to me in college, by the way. And let's see here. So then we talked about the code, and we used the forward, turn left, turn right functions, and said basically, if the whisker is pressed, maybe if one of the whiskers is pressed, back up and turn right. If the other is pressed, back up and turn left. Otherwise, go straight forward. And so there's a whirlwind kind of review of some of the main points that we've talked about from the book over the last couple of days. Now let's get on to infrared, although I should probably check for questions first. Let's see, when plugged in, okay, so just the same question about the polarity of the resistor. Any other questions before I move on? Okay, well, you can always feel free to jump in or chat me. Okay, so some cameras will do this and other cameras won't. My Samsung phone works pretty well on this. And if you have a TV remote, an old school one where you had to point it at the TV, now they're switching over to radios. When you don't press any button, or you can press and hold the TV remote's button and look straight into the part that you point at the television normally, and there is no apparently flickering light. But if you look at it through some phone screens and document cams, what you will see is you'll get a really good look at the flickering light. It's infrared, which some phones typically, my experience has been that iPhones filter out that infrared, whereas Samsung phones let it go through, and I don't know anything about Google Pixels. But there are many cameras that you can use where if you point the remote at the lens and press and hold the button, you'll be able to see a flicker, and it's really fun for kids to see that. So I recommend having a TV remote on hand and putting that in your document camera and checking to see first if you can see it, and then if so, show it to them. Let me see, I have a remote right here. So let's see if I can get that to work. Okay, so I am not pressing the button. Now I'll press and hold the 8. Is that coming through? Stephanie, can you see that?
Yes.
Okay, and pardon me. So we are not talking about the indicator light that's telling you that the signal is being sent. We're talking about this light right here. That is the flickering infrared light that's sending messages to a television. And that's talked about in the book on page 217. And so we talk about it a little bit in reverse order, but for a quick presentation, it works a little bit better to go this direction. So I'm going to actually go backwards for 3 pages. So starting out, we have the flickering light that you can't see unless you put it through a camera. And not all cameras do it. Many do, some don't. Then there is a little device that will sense that flickering light inside TVs where an infrared remote is used. And again, some remotes are radio and you don't have to point them at the TV, but the kind that you do have to point at the TV, you might find an infrared remote in there. But what we do is we take that infrared LED from the TV remote and then the infrared detector from the TV itself. Again, these are real electrical and electronic parts that students work with, not just some prepackaged thing, which for many classes, they find that to be advantageous. And so if there's nothing in front of the robot, the Arduino in this case is going to make the IR light flicker, but it's just going to go off into infinity. But if there's an object in front of the ShieldBot, when that flickering light hits the wall, it'll bounce back and the receiver will see it. And it actually sends the same kind of signals to the Arduino that the whisker did. So then we talked about this, finding and putting together your infrared LED in the tube. And then here is a recap of page 220 through 221, which is building this circuit. And so what I would like to do now is, first of all, finish my circuit as we're talking about the circuit. Okay, is that fairly visible? Hopefully. So what I have so far Go ahead.
Yes, it's very visible.
Oh, thank you, Stephanie. All right. So what I have so far is everything but the resistors, and I also forgot the piezo speaker. So I guess I'll start with the piezo speaker connected to P4. And let's see here. All right. The first thing is to make sure that your, well, I better just add my resistors and finish building the piezo speaker here. So I had to be really careful as I did this to make sure that I made a note of which row my piezo speaker is in, and I'm hoping that I got it right. And then drop that into P4. Okay, so next we're gonna do resistor values. So I will have you verify your resistor color codes as I put them in. So the first verification I'd like to do is I'm looking for the red, black, red resistors. I believe they're in this one. Yeah. So here is a red, black, red. And here is a second red, black, red. And that's 2 kilo ohms using that little table and diagram that we talked about a few slides back. Now, if you have trouble seeing those resistor values, the thing that I recommend is to use your phone. If you don't have a magnifying glass handy, what you can do is most phones either have a pre-installed magnifier app or you can download an app. So here is my magnifier app running. And if I can keep the phone still for a second, as you can see, we can zoom way in on those resistors. And that's just halfway, like can zoom in so far that I can't even find the resistor. Let's try. There we go. So you can definitely see, hopefully, that that's red, black, red. I'm going to zoom out a little bit too. So there we go, red, black, red, with a gold stripe, which all of the resistors in our kit are going to have. Then there's a couple of red, red, brown resistors that we want to bring out. Another way to do this, especially for the vision impaired, is and by vision impaired, I'm primarily talking about color blindness. For colorblind individuals, there's a device called a multimeter, which here is an example of one of the multimeters we have in the Parallax office. And what they can do is set it to measure ohms. And then basically it has a couple of probes that you can touch to the resistor leads. It also has an alligator clip option. Let's try to hold it to resistor so that we can get a measurement. And so 218 is pretty close to 220. That's what the gold band talks about, is the tolerance. These are 5% resistors, so 5% off from 220 is acceptable, and only less than 1 ohm or less than 2 ohms off is definitely a 220 ohm. So for colorblind students, they can I'd recommend getting some voltmeter measuring devices. Stephanie, if you could multimeter, pardon me. Stephanie, if you could paste the link to the parallax multimeter, that would be a really great thing. Okay, so with all that out of the way, what we want to see is on pin 3, one of the 2K, that's red, black, red, goes to the anode of the LED. And this, so the anode should be the longer pin. So you want to have the longer pin connected to the very bottom row, and then the shorter pin connected to the same row as the middle pin of the IR receiver. And then that goes into pin 2, pardon me. So everybody please check to make sure that red, black, red is what you've got connected to the longer pin of the IR LED, and then that's going to pin 2. Next up, a red, red, brown resistor, that's 220 ohms, needs to go to the bottom of the 3 pins of the infrared receiver. And make sure that everything sinks in by 1/4 of an inch. I'm bending the lead on this instead of getting it to sink in. There we go. And then the other end goes to pin 3 along the side, or rather the socket 3 that's labeled 3, digital 3. Next up, check to make sure that the 4th row from the top gets a 2K red, black, red resistor. By the way, technically, you're supposed to have the power turned off and unplugged while you do this. Okay, and that one goes to pin 9. And then the RIR receiver gets the 220 ohm red, red, brown resistor. And then that goes to pin 10. So with all those resistors in, then the other thing you'll want to check is to make sure that your jumper wires to 5 volts, which are best with red coatings, to make sure that you're tracking what's connected to power and what's connected to ground. By convention, we use black as the ground connection and red as the power connection. So this goes from 5 volts to the power input for the first IR receiver, And then we jump that down to the 5-volt power input for the second IR receiver. So please do double check all your connections. And then what we'll do is we'll run a test sketch to verify that everything is working. And this test sketch, the students do it one at a time, and then they build some light indicators. And so this is the test sketch that uses light indicators as well, LED lights to tell whether or not the detector see an object, but we'll just use the terminal. So I'd like you all to open test both IR and indicators.
What chapter is that in?
That is going to be in chapter 7.
Thank you.
You're a little ahead of me. I was just on my way to do that. So again, that's File, Sketchbook, chapter 7, test both IR and indicators. And when you run this,
Hey, Andy,
yes,
we do have an observation. It looks like your top 2 are in the wrong spots according to the picture. You want
okay,
to double check
so
those?
yeah, let's try to take a closer look. Let's see if
It's
I can
really-
zoom in on this
It's
guy.
hard to see on the black background exactly where you're.
Yeah, there might be some parallax going on here.
Are you going into 8 and 9 there?
I believe that.
And
I believe that I'm going into 9 and 10.
into 9 and 10. Okay.
And so the picture hopefully matches that. Yeah, I see 9 and 10 on the schematic. My phone is sitting on the picture.
Okay. So it was just an artifact of how
Yeah,
the camera was working.
It's just the camera angle, and I'm sorry about that, everybody. Then we have 1 and 2 down here. See if I can give you a good angle. There's 1 and 2. And there is, it really is a 9 and 10. Although we'll have some proof as to whether or not I did it right in just a second. Okay, so go ahead and upload that to your Arduino. And it's telling me that I forgot to connect my USB cable. So you'll want to set your 3-position switch, the power switch, to position 1. You can have your batteries plugged in or not. It actually doesn't matter for this particular activity. And then obviously the USB cable. And I'll run this again and hope that it works. And after you run it, after it loads, go ahead and open the serial monitor. And what we want to see is very similar to what we saw with the whiskers. We want to see ones scrolling down our our screen. And you know, these ones are scrolling down so rapidly that I'm concerned that the online IDE on many of your computers might have some challenges displaying it that quickly. So what I want to do is actually go in and introduce some delay here. Let's delay it so that we're only getting 2 per second. Yeah, just to err on the side of caution, I think I'd like to put a delay of 500 milliseconds. That's half a second into the sketch. And now go ahead and reload it and reopen your serial monitor. Okay, and now we can see that they're marching slowly down the screen as opposed to, or down the monitor instead of racing down it. And what I'd like you to do as you test this is to keep an eye on the bottom numbers. And so put your hand in front of the right detector, and you want to see the right column start showing zeros. And then when you take your hand away, it'll start showing ones again. And you can keep your eye on the bottommost pair of numbers as you're doing this. And then put your hand in front again, take it away. You should get reliably 1 and 0. Then try that for the left detector. And you want the left one to turn to 0 as you have an obstacle in front of it, and then turn back to 1. And then you can also figure out basically how far away, what kind of range you've got by gradually moving the robot back from, say, a book. And as you can see, the range is pretty far out. I just took the book away. Yeah, my range is impressively far with the book. And then if you take a different object, like say a cardboard box, it's going to be not quite as reflective as infrared, or maybe, for example, even a white page should diffuse it a little bit more so that. Okay, so I've moved it back about 2 feet. And now I'm finally getting some zeros and ones. But if we're up close, it's definitely giving me zeros. And you can take something like your book and move it so that only the right detector sees it, or only the left detector sees it.
Andy, can I ask a quick question?
Yes, please.
How did you make it so that I can see the zeros and the ones? I missed that piece right there. I
Oh,
rounded
no
off.
problem. Which
The online?
you're using the online. Okay, so that's going to be on the left. So do you see a little magnifying glass? That's the fourth
Okay.
button down on the left.
Uh-huh.
That is the serial monitor for you. And
Okay.
it'll appear in this area right here. It'll replace the let me see if I can. Okay, so I'm going to close my serial connection there and try opening it here and hoping for the best. There we go. So now you'll see your ones right there. And hopefully they are ones when nothing's in front of it. And then when you put an obstacle in front of it, it's 1, 0. If it's on the right, the right side of the bot, if it's on the left side of the bot, it should be 0, 1. And then
I'm
if you
getting
do
all zeros.
okay, you're getting all zeros, which means it thinks it sees something the entire time. And that is what that means. Well, you're getting all zeros. Try pointing it at the ceiling.
Still zeros.
Still zeros. Okay, just I'm going to point mine at the ceiling, hopefully. Yeah, so see how I've got ones pointing mine at the ceiling?
Mm-hmm.
Now it sees the document camera above me, so that's why I'm getting some zeros if I hold it in the camera. All right, so let's go back And the students, this is something that the students will invariably have to do. So even if you got yours working, it's worth watching this because we're doing the troubleshooting that a certain percent of your students are always going to have to do. And it's a learning experience on essentially the unforgiving nature of electric circuits, that they have to be wired just so before they start to work. There can't be anything off or vague about it. So the first thing I would do is check to make sure that you're in, let's see, you're getting all ones. And so check first that your 5 volts is going to the top row. And then you've got a jumper from that top row to the topmost pin of the lower infrared 3-pin infrared receiver.
I just saw make sure it's on 1. And when I switched it to 1, it did get me 0s and 1s. Okay.
You know, I should have done that first. Okay, good job. Now, does anybody else? Oh, and thank you, JM, for that suggestion. Now, does anybody else have a not working infrared detection system at this point? Can you give Stephanie thumbs up and thumbs down? And Stephanie, can you tell me when you've got, say, more than 5 thumbs up?
I see 3. I think we might need a little bit here. Oh, another one, another one, 5. Okay, so
And we got one in the chat too, so that's 6.
yeah, they don't stay thumbed up forever, so they're
Yeah.
popping in and out. But I'd say we've had at least half give thumbs up, but some have not yet.
Okay, and we got a couple in the chat now. All right, well, great job, everyone. This was considerably less troubleshooting than we've had to do in previous workshops.
Should we ask for a thumbs down if somebody's profoundly stuck?
Yes, please.
I am not seeing any thumbs down.
Right on. Congratulations, everyone. All right, then. So let's try. So we already tried test both IR, and thank you for another one in the chat. By the way, these are excerpts again from the textbook. And I'd like to point out that in the textbook, it's very meticulous in its approach to this and really all the other activities, that you start out with a parts list. So like if we're in chapter 7 here, we're in activity 1, and we start with a parts list, then some assembly instructions, then a circuit, then a sketch. And beyond that, there should be a how it works and a your turn. So here is the your turn. I'm missing the how it works here. I think possibly the how it works is discussed ahead of time here. It's explaining what happens before the students try the sketch. Then we also have field testing, which we're not going to do. And that was, I mentioned, where you add LED lights. And then this script that you're running right now will actually make the lights go on and off, depending on whether or not it sees an object. And there's also range adjustments. And as you can see, there's still a parts list. Since the circuit has not changed here, there's no circuit. Talk about how it works, try out the example sketch. And there's always these little check mark checklist instructions for the students to follow along to highlight that there are action items. And then the testing procedure, and then something where the student tries some different things. And in this case, what they're trying are different resistor values. Remember, I mentioned that a resistor resists the flow of current. It means that if you use a smaller resistor, more current will flow through. If you use a larger resistor, less current will flow through. And in the case of both visible and invisible lights, students will discover that less resistance means a brighter light, and more resistance means a dimmer light, and less resistance in the case of a brighter infrared flashlight will mean that it can see objects further out. A larger resistance means the object has to be way closer up in order to see it. And so they'll be trying different resistors and then set their detection range to what they want to have for their robot. And after that, there's an avoidance, a detect and avoid objects. And this particular one does it the same way that the whiskers did, where it actually behaves as though it bumped into an object and backed away and then made a turn. And I think that actually this isn't such a bad one to try out, just to see it behave the same as the whiskers, because the signal that the Arduino is getting is the same as the whiskers. So let's try roaming with IR. And so roaming with IR, again, that's in chapter 7. For those of you who are using the serial monitor, you'll need to click to the little folder button. It's labeled sketchbook. So monitor and sketchbook, go back to your sketchbook, and then find roaming with IR, I believe. Yes, roaming with IR. And for the Arduino IDE, you're going to use File, Sketchbook, Chapter 7, roaming with IR. You can close and make sure to close the terminal, especially close the terminal if it's open. Mine is not currently open. Because the Arduino IDE always opens a new instance every time you open a new sketch. So close the terminal so that the old instance with the terminal connected doesn't get in the way of your loading code to the new one. Hit that right pointing arrow. Make sure you've got your power switch in position 1. We're now waiting for it to compile and then load into the Arduino. Okay, I just heard my my speaker go off, so now I know the program's running. So you can actually, if you've got enough table space, you can leave it connected and basically just get ready to catch it so it doesn't go too far. You can even hold it up when you set the power switch to 2. Okay, so it's basically going forward because it can't see any. Oh no, it's trying to turn. No, it's not. It's basically going forward right now. And so we'll let it go forward, and then it sees my hand and turns. See if I can. Sees an object in front of it. Oops. What I'll do to demo this is let it go forward, and then I'll stick the book in front of it. And there it went and backed up and chose a new direction. You can also hold it up, and if you can see, it would be hard to see on the camera, but if you can see the direction the wheels are moving, you can also just point it at the ceiling and put your hand in front of each detector to see how it affects the wheel motion, and even both detectors, and it'll back up and turn and keep on trying to back up and turn. Okay. Has everyone been able to verify that that works kind of like the whiskers did?
Getting some thumbs up. 1, 2, 3.
And I have a one, I like it better than the whiskers, and most folks do. The nice thing about the whiskers is it's a physical, tangible thing where students really can see that there's an electrical connection being made. So we always start with the whiskers. And good, I'm getting some, it worked in the chat. Thank you for those chats. How many thumbs up have you had, Stephanie?
I had a smattering 4 or 5 come through at different times.
Okay, just give us a thumbs down if you need more time or a shout out or a chat. Otherwise, what I'd like to do is try fast IR roaming. And again, I'm just jumping to another activity.
Some enthusiasm and no thumbs down.
All right. So so activity 4 was the basic avoidance, and it's very much like the whiskers. It's just it doesn't have to make physical contact. The thing is with infrared navigation, what you can do is check, and if an object's in your field of vision, turn a little bit, and then check again a 50th of a second later, and check again, and just adjust incrementally as needed. And then when your field of vision frees up, you can go forward again. And by checking 50 times a second, it makes a much higher performance application. And so this is activity 5 in chapter 7, and it's called fast IR roaming. So we'll go and open fast IR roaming. Sort by name. Fast IR roaming. And then, oh, did I close my Arduino IDE? Okay. File, sketchbook, chapter 7, fast IR roaming. And hit the arrow flash button. Make sure your switch is in position 1 and that you've reconnected to USB. There, that ought to give me a little bit more room. Okay, I just heard the speaker go off, which means that my sketch has started. And this is a good one to unplug and put on the floor and see just how well it does. I'll go ahead and unplug mine.
We have an observation that the problem with the whiskers is the height.
Oh, yeah. So if you have something that's below whisker height, the whiskers won't touch it. That often leads to discussions robotics wise about redundant subsystems. Some of the other things that we've noticed is that ultrasonic detectors don't work very well on teddy bears because they muffle the ultrasonic pulse, and so it can't bounce back to the receiver. With the infrared here, sure, it might see a slightly lower item, although you can't really get too low, but items that absorb infrared like vinyl electrical tape and the black, is it called Cove base, Stephanie?
Yes.
That is around the base of the floor and comes up about 6 inches on the wall in many schoolrooms, also is mostly invisible to infrared. So use an object like a cardboard box, which will reflect it pretty well. So here goes my robot, and I put my hand in front of it.
Oh, we have a question of the name of the previous sketch.
Oh, okay. The name of the one that we just loaded, or the name of the one before it?
I don't know.
Okay, the
one
name of the
before-
one we just loaded,
Okay.
and it's one of the favorites from the book, is Fast IR Roaming.
And the one before that?
The one before that was File, Sketchbook, Chapter 7. Roaming with IR. So roaming with IR is like roaming with whiskers. And then fast IR roaming is something you can't really do with whiskers. It's only works when you have infrared and are able to see things a ways away. You can almost see how it responds to my hand and incrementally turns away. And then when it sees its path is clear, it can just keep going. And then there's some boxes holding up my, you can't see that quite yet. If you trap it in a corner, now it's trying to turn away from my hand and from the box. Okay, so here I'm keeping it trapped between my hand and the box, and then when I pull my hand a little bit away, it makes it through. I'm going to try to give this my camera just a little bit more height for a better demo. Stephanie, did that look okay as far as a demo goes? Or Ari? Okay,
Marcel had thumbs up.
I'm sorry?
Marcel had a thumbs up.
Oh, thank you, Marcel. Excellent. Sorry, I forgot to ask you. Okay. And then how's everybody doing? Did we all get that to work?
Seeing a smattering of thumbs again.
Excellent. And I'm getting some yeses in.
May I paste in that clear the table competition idea since it relates to the circuit? And what we
Yeah,
talked about
sure.
out sensor redundancy?
Yeah, that would be fine. I'll actually, is that a YouTube video that I could play?
I think it has one on the page.
Okay. Yeah, I'll follow that when you paste it in.
Yes, I have pasted it in. It does add, I think this one added sensors from the QTI line follower.
Yeah, so it's detecting the white table edge. And when it detects that, or it's not detecting the black table, it's detecting the white edge of the table.
And it's doing that with the little QTI line sensors, and then it's using the IR detector circuit you just built to locate the flower pots.
All
Or push
right.
them off.
And yeah, another thing about that is the QTI line sensors are available as an optional add-on for this robot.
And part of the 12-pack plus kit, if you
Yes.
get the class pack. Okay, end of commercial.
Okay, thank you for that. All right, well, how about if we take a quick break and come back at 10 past? It's currently 2 minutes past the hour, going on 3, so we'll reconvene at 10 past. Stephanie, can you pause the recording?
I do have a question.
Okay, there was a quick question from somebody. Go ahead, please.
If I pull out the IR sensors while the program is running, not the sensors, but the UV lights.
The infrared LEDs.
Yes, what
Yeah.
should my program be reading? 0, 1, or 0, 0? What should it be reading?
If you remove both infrared LEDs, if you remove one infrared LED, you'll probably get a 1 for that side. If you remove both infrared LEDs, you'll get 1, 1, because the infrared receivers in theory should not be seeing any reflected IR. What that does bring us to, though, is the next thing, which is one of the activities that we kind of passed by was the infrared interference sniffer. And this is where you run a sketch where it's not sending any light out the LED, it's just listening for interference. And if you point a remote at it, it will and press a button, it will beep, letting you know it found interference. Fluorescent lights are sometimes sources of interference. And so we do this actually before any of the navigation, just to rule out that that a classroom, or just to try to determine if a classroom has fluorescent lights that interfere with the infrared receivers.
Because I have pulled out both of my.
Okay, you should be getting
eyes.
ones. If you're getting zeros, it
I'm
means
getting a 0, 1.
okay. And
Pulled
then
out both of them.
and then there could be a problem with the circuit that you have. Were you able to have good navigation already?
No, I've been getting a 0, 1.
Okay, so that brings us back to our troubleshooting tips. The main one is, of course, to revisit all of your electrical connections and just
Right.
do your best to make sure that everything's plugged in, that all the resistor color codes are right, and that every little piece is connected as shown in the
Okay.
in the diagram. Now, which side are you getting zeros on, regardless of whether there's an infrared LED?
On the left side.
Okay, the left side.
The
So
first
that's,
number. The first number.
oh, the first number. Yeah, that would be the left side
Uh-huh.
here in my slide.
Right.
Okay.
The other one, right now, I have a 0, 1. I have both eyes in and getting a 0 and a 1.
Okay. So
Right.
what we want to do is check to make sure that the jumper wire from 5 volts is on the top row, as is your top pin for the receiver.
Yep.
Okay, now go down to ground and follow your ground wire. Your ground wire should come up to the lower infrared receiver and go to its middle pin. And then from the middle pin row, another jumper wire goes up to the middle pin row of the upper IR receiver.
Okay. Goes to the middle pin, correct?
Yes.
Okay. I think that might be the problem. I think I got it doing at the bottom pin. Okay. Looks good.
All right.
I think I got it. Thank you.
Now, and of course, you'll need to check the other two details, that the lowest of the 3 pins is in the same row with the lead of a 220 ohm red brown resistor. And then that other lead is going to socket 10. And then of course, that the short pin of the IR LED is in the same row as the center pin of the receiver. And then the long pin of the IR LED, the anode lead, is
It's good.
basically
We're
4
good.
rows down. Yeah. Okay. Oh,
Good.
did you test it and now it works?
I just tested it. It was the ground. The ground was in
Okay.
the wrong one. It's going
Okay,
to the
fantastic. And
lower
so what
pin
that
center
means
one.
is you'll be able to try out these sketches, after we finish.
Will do.
Okay, good. And
Thank
so,
you.
yeah, your timing is perfect, because I was going to mention troubleshooting. And of course, the first thing to do is to, take a look at the PDF version. Page 221 is the color, and you can zoom way into that. So here I am at the PDF. I'll go to 221, and then control scroll wheel. And for example, if we want to look just at the left, well, it only zooms to 500%, but that should be good enough to get a really clear view of your circuit. And in fact, on my monitor, I think 400% would be better. And there we are. So yeah, this is going to be your clearest view of the wiring diagram. Check all the resistor values and etc. You can go ahead and read these at your leisure. Slide 115. Again, there also is sometimes the possibility of fluorescent lights. If your shield bot seems like it's seeing its own shadow and just shying away from everything, it may be that you have fluorescent lights that are giving off infrared interference. And so turning off the lights in the room can help. Usually there's one light by the door that stays on in the classroom. And then hopefully that's not too powerful. Also, staying away from direct sunlight is going to be important for it to be able to see obstacles.
We have a question.
Yes.
If I put the LED lights in, does it tell when it sees something on the right or left?
It does. So if you add the LED lights, and if you have code in your sketch, then yes. Let's see. And Marcel, you're using the Arduino IDE. Okay. So what you'd be looking for to test with the lights is Sketchbook, Chapter 7. Test both IR and indicators. Now, that said, you'll learn how to test the lights in both IR and indicators. And then in the textbook, it challenges you in fast IR roaming to add in a feature to use those lights. So that's not a given solution. That's something to challenge the students to go in and do some code surgery and add a feature. All right, the last activity in Chapter 7 is basically looking down, and there's a variety of ways that you can make a tabletop. The one I recommend is using poster board and then several strips of electrical tape around the edge to give it a border. This border will absorb infrared and it'll look like a drop-off without actually being a drop-off. Because we don't want the robot to potentially take a spill. There's also various marine tapes that can be used. They're usually waterproof tapes that are like 8 inches wide that you can get at Home Depot, and that's a lot easier than taking a whole bunch of strips of electrical tape and putting them edge to edge on a piece of poster board. All right. Before we finish, let's do the BOE ShieldBot Shadow Vehicle application. That's going to be in Chapter 8, and and first we want to test and make sure our distances are okay. So it's File, Sketchbook, Chapter 8. and then display both distances. And what you'll want to do is run that. Again, the sketch name is display both distances. And you'll want to run that and then use the serial monitor. And again, the serial monitor is the upper right in your Arduino IDE. And if you're in display both distances here in the online editor, after loading it, you'll want to hit the monitor here and it'll show in this area. Oh, I'm not connected. See if I can get connected. No, because I've been using the Arduino IDE. Oh, no, it's because I have the USB cable unplugged. Okay, so now I'll flash it. And I'm waiting for the upload to complete. Looks like it's running. So now we'll hit the serial terminal. Maybe now. There we go. Okay, and I'm actually going to disconnect here and run that where I can get a better view of it in the Arduino IDE. Its serial monitor lets me zoom the text, which is not a feature of the online editor at this point. Okay, so here we are, and you want to look at the bottom pair of numbers again. And what you'll find is that if you put your hand in front of the robot, okay, so I have the serial monitor behind the screen here. And what I want to do is put my hand in front of the robot. Okay, so my hand's on one end of the screen, the robot's on the other. As I come closer to the right, I want to see it start to display distances. And it's usually about a foot out that it'll start to show me distances. And as I get closer, we'll see a tendency towards smaller numbers until I get really close. And then we're down in the 1 and 2 range. Oh, there's 0. There's 1, 2, 3-ish, 4, and 5. And basically you want roughly the same for both sensors. So if you put something wide in front of it and get closer and closer, you'll get roughly the same values with both sensors. It's not going to be exact because the resistor values differ a little bit, but it'll be fairly close. And once you're sure of that, if you're not like all zeros and still 5s on one, you're probably okay. And then you can come in and try the file sketchbook chapter 8 following shield bot. Following shield bot is the sketch to try next. Make sure to close out your terminal on the before opening or since your Arduino IDE is going to open a new window, the terminal would prevent the IDE from being able to load the sketch. All right, and then go ahead and load this sketch with the 3-position switch on the shield bot, set it to 1, and then run this sketch. And this one should do a pretty good job of following your hand or going at a wall and then coming to a stop in front of the wall at a certain distance. I'll have it follow my hand under the camera here. Okay, so it's running. So I'll go ahead and set it to position 2. Unplug the USB cable. See if I can have it follow my hand. You should even be able to push it backwards. It's usually pretty good about following. And maintaining a given distance from an object. Many have likened it to a duckling that has latched on to its new mommy. Okay, can I get some thumbs up as to, or Stephanie, do you see people, are people still, yeah.
One thumb, two
One thumb.
thumbs.
I got Marcel saying I like that. I like it too. I think it's all of our favorite application from the textbook. Thumb up on in the chat. Ah, yes. Now I got a tip from Stephanie so I can see the thumbs up. How many thumbs up do we have now?
There goes
Okay.
another. Yep.
Okay, got 2 in the chat, 3 in the 4 in the, or
And you missed a few that came through before.
yeah. Okay.
Any thumbs down from anybody stuck?
There's some more thumbs up coming through. And even more. Okay, I'm not seeing it. Give me a thumb down or wait a minute or something if you're stuck and it's not working for you. In the IDE, how do I access the serial port? So you will
Serial
not.
plot.
Oh, the serial plot. Gosh, you know what? My IDE is a little bit older, so I don't have the serial plot. We don't, yeah,
It's right next to the serial monitor.
in yours,
In mine.
Marcel.
Well, if
Mine's
they
a
have
little old. I don't have any, but yeah, okay, I get it. You're okay. So Len, that is where it is in the upper right. It's next to the serial monitor in Marcel's newer version of the IDE. And then there's going to be an Arduino page that explains how to format your data to send it to the serial plotter. All right. So in the classroom, it's a lot of fun to put a half circle sheet of paper on the back of your robot and to give and see how long a string of robots, basically the front robot will go very slow and it'll use in fast IR roaming, but you'll slow down the fast IR roaming code so that it's going slowly enough that it doesn't lose its followers. And it's kind of fun to see how many you can line up of the classroom's robots. Education wise, there's, or science wise, there's a frequency of flashing light that the Arduino uses. And we normally use 38,000 on-off flashes a second. That's what the TV sensor will register as, hey, I see it. And it has a filter. And basically that filter makes the makes it less likely to see it if the frequency is, say, 39 kilohertz, then it's only 80% sensitive. And at 40 kilohertz, it's only about 50% sensitive. And at 41 kilohertz, it's less than 40% sensitive. And so we use this in the infrared detection scheme to say, hey, let's use our best frequency of 38,000. And if we saw out this far, we know there's an object there. And then we'll use our next best frequency and see if we can still see it. And then our next best frequency and all the way down to the worst frequency. And basically what you can do is you're in zone 3, and it turns out that counting the number of times you don't see it, 0, 1, or 1, 2, 3. So we don't see it 3 times and we do see it 2 times here. And so by counting the number of times we don't see it, we can tell that we're in zone 3 or whatever zone the object happens to be in. And then here's an excerpt from the textbook and a code excerpt from the textbook along with page references. And this is also science-wise an example of proportional control from the control systems world. Basically, what happens is each wheel is coupled with the infrared detector on that side, and so we do a set point. We want to keep the object in zone 2, and if the object is really in zone 4. That means the difference between what we have and what we want is a subtraction problem where we're -2 off. And essentially then we'll multiply that by a number, and that number will give us some kind of favorable output value that we can use to control the servo speed. And then we update the speed, then the system might move on us. Somebody might move the object that's in front of it, or just the fact that it adjusted itself a little will cause a different measurement. And so the next time around, the measurement might be 3. So the error might be -1. And so the output might be 50 after multiplying it by 2. And this loop goes round and round again. And the code actually does that for you. And we introduce things like constants, proportional constants, and set points. These are all control system terms. And we have the students fill out the control system calculations for the different measured distance options so that they can get a better feel for what's going on. One of the activities that we skipped, but that's a lot of fun, is light navigation, where you build a light sensing circuit and then shine a flashlight at the robot to guide it around. And so the light sensor in the kit is called a phototransistor, and we introduce it in the textbook along with its schematic symbol and how it looks compared to the infrared LED. We talk about the visible light spectrum and where the sensor falls in the spectrum and what it can detect. And then we do some very basic measurements with the phototransistor using one of the analog input pins. And we look at the voltage that the transistor gives depending on how much light is shining on its surface. And then we talk about how Ohm's law works and how basically the amount of current, which is voltage, is current times resistance. And so if you have a measured voltage, you can use these three values. You have a measured voltage, you know the resistance, so you can figure out the current. And also you can, if you know the current, figure out the voltage. Well, we also use a circuit that measures decay time using capacitors, which are like very small batteries. And so we have two circuits where there's a capacitor in parallel with a phototransistor. And of course, we show how that's wired as was the case with the whiskers and the phototransistors. And this is kind of fun because we measure, basically, let me jump ahead here. I think I'll just use this. The way it works is that the sketch will set P8 here high. And what will happen is that this capacitor, which is like a very small battery, will charge up. Then when the sketch sets P8 to input, there's nowhere for any current to go and no current charging this capacitor anymore. And what happens is that phototransistor, which again conducts more current with more light and less current with less light, well, whatever amount of current it conducts will affect the time it takes this capacitive battery to drain through the transistor. And what the Arduino is able to do through the sketch is measure the amount of time that the voltage that the capacitor applies across the transistor decays. And so this is an example of voltage decay where you have a resistor and a capacitor. This is a variable resistor called a potentiometer here. And so it decays, it actually shows us exponential decay here. Well, if you use a transistor instead of a resistor, you get more of a linear decay, but the speed of the decay still changes. And so this is brighter light here. And so the Arduino measures when it starts to decay, and then when it makes it past something called the threshold voltage. And let's see here. Sorry, I was checking the chat to see if there was a question I needed to answer. Anyway, you get decay times. And so this is a faster decay, meaning a brighter light that caused the phototransistor to conduct more current and drain the capacitive battery faster. And then this one here is a dimmer light. It's decaying more slowly. And again, it measures from the time it set its pin to input to the time it went below the 0-1 threshold. And that's what it uses, along with some clever math that basically takes the total amount of light and then figures how much of that the right side represents, for example. And essentially you can see how much of the relative light or shade actually is measured between the left and the right sensor. And so, for example, if you put 16108 in the numerator and then 16108 plus 1372 in the denominator, you'd get 0.42. And then putting the light on the other side, you get negative 0.4 and so on and so forth. And so this is a way of figuring out, relatively speaking, how much light of the total measurement is on the right versus the left sensor. Knowing that, you can say, oh, well, it's kind of shady on the left side here. So let's go ahead and slow down the left wheel. And what that'll cause it to do is turn toward the light, which is on the other sensor. So the right side is getting shade. We want to turn left to turn towards light because that's what the application is about. And so the left wheel slows down. And that's what the sketch in the book does. All right, and so that's basically the kit that you have, and what is what is covered in the textbook, and we got to try lots of fun examples during the workshop. And so now I'd like to talk about equipping yourself a little bit. The first and most important thing in my mind is replacement parts. So if you need replacement parts, you can go to parallax.com and search for small robot. And you will see all kinds of different parts that will go on your robot. So this is one way to find the part. Here's the tail wheel, the cotter pin that attached the tail wheel. Here are the nuts and bolts. I recommend getting several extra sets of these if you're equipping your classroom with robots. We also have things like individual whiskers, but I'll jump to another view, or no, let's go to page 2 because there's more small robot stuff. Okay, so here's the small robot electronics pack. This is another one I'd recommend getting a couple of if you're equipping your class so that you can have extra parts. So if an LED rolls away, you've got some extra LEDs to hand out to the students who need them. And then wheels and rubber band tires don't apply. Here's the battery pack. And another way to find parts is you can search by a specific part number. So on pages 10 through 13 in the textbook, maybe I should have said 11 through 13. Sorry about that. On pages 11 through 13, we have pictures of each part and their part number. And so their part number is usually 3 digits, a dash, and then 5 digits, with the exception of a few things like the Arduino and the BOE Shield. Those are just 5-digit numbers. And so you can find a given 5-digit number. So let's say that you're missing a, let's say that I didn't try this beforehand, so I don't know if I'll be able to order some of these things online. Let's try the pan heads. Let's try a whisker. I'll bet I can order a whisker online. So here is a whisker. And so here's its part number, and going to parallax.com, and we'll paste the part number in the search and see what comes up. Okay, and I like this because what we see is both the individual whisker and that the individual whisker is in the small robot electronics pack. And so, so that's an example of finding and getting any replacement parts you might need. I talked about the applications like the ultrasonic turret and the infrared remote control earlier on in the session, and we looked at some videos of the activity bot doing equivalent stuff. And those type of things are documented down here. It's on the ShieldBot page. I'll paste this in. And so we can go ahead and look at the main ShieldBot page in learn.parallax.com. And we have our textbook link right here. So this is the online version of the textbook. Now, I advocate using the printed textbook because that way students are going to be more likely to hand enter their sketch. But this is another resource that we make available. Unfortunately, it's all too easy to shade copy and paste sketches from it. And for many classes, that may be appropriate after the first little while anyway. So here is ping roaming, the infrared remote control one that I mentioned earlier. So if you have a TV remote and you can set it up as a Sony, this will work. And And here we have a little YouTube video of it. So the 2 and the 3 pivot, or I mean the 1 and the 3 pivot. I'm gonna go back and replay that. But first I want to show you that the these right here are is the legend of the buttons for control. So 2, because it's in the front center, is for forward. 1, because it's in the front left, is for pivot forward left. 6 is rotate right, 4 is rotate left. 7 is pivot backwards to the left, and so on and so forth. 8 is backwards. And knowing that, this video should make some more sense. So I'll go ahead and restart it. That looks suspiciously like my thumb. I don't remember if I recorded that one, but I suspect so. Oh, and here is here's a fun one too. Just a quick look at the following shield bot. Advertising.
We have a
Skip.
question.
Yes.
Can you show any real world situation that this robot technology would be used? Example, would this style programming be used in the Roomba vacuum?
Well, yes, it is. At least the Roomba is going to use infrared and probably ultrasonic and some others to, you know, detect obstacles around it. And so, yeah, the Roomba is definitely an example. I think another one I call out in the textbook is simply the conveyor belt at a grocery store. There's an infrared transmitter and receiver at the end of the conveyor belt. Let's try this again. There we go. And also, because of the fact that these things are real world, another example is the faucets in say airports that you wave your hand in front of. Those are going to be another example. And when I was shooting this video, there was one time where the leader didn't see the edge of the table and went straight off, and the follower followed it very faithfully and also went straight off. And I really wish I'd have somehow saved that. I'd love to show it to you, but I haven't been able to find it. We have kits and add-ons, and there's I'll go ahead and give you the link from the slideshow for the accessories. Wow, hey, look at this. I finally got my, you won't be able to see it, but I finally got the ability to see all of you again. Something about maximizing and minimizing that YouTube video. So it's good to see you all. I couldn't see you the whole time, and sorry about that. Okay. So I'll go ahead and paste in this link to All Things ShieldBot. And then we'll go ahead and take a look at it. So we have a 12-pack, which in addition to the kit that you have, it also has an ultrasonic sensor, a turret servo, and that's for the rotating ultrasonic turret. And it has the QTI line sensor so that you can put your robot on a piece of electrical tape that is making a course. And it can also act like a sumo bot, where it detects the edge of a table and backs up and turns. And so this is an example of the 12 pack. And again, we've got the TV remotes, the ultrasonic sensors, the servo turrets, and then those are all available from learn.parallax.com, ShieldBot, and then on the main page, here's the main textbook that we went through and tried a whole bunch of examples from. But here is roaming with the ping. Here is the TV remote. And then I don't see the QTI code in here. That's funny. I know that we have that documented for the Arduino. I'm guessing it's on the product page. So if we go to www.parallax.com and then search for QTI, and then look at the QTI line follower kit. No, that was not the right one.
It's right there at the top left.
Oh, this?
Oh, top right. Sorry. Yes.
Oh, okay. Yeah, I saw the robot and didn't realize what I was looking at. Thank you.
Yeah.
Okay, so here is the QTI line follower product page. And if we look at downloads, we have instructions on how to put it together right here. Try that again. That's weird. Maybe if I just left click it, there we go. Okay, so then we get a zip file that I'll unzip and open up. And then what we have here is here's the ShieldBot zip file. And so there is the code. And then there's also a guide for putting it together in PDF format. And so this takes you step by step through how to build the QTI sensor. So that's where the QTI resource is. And then the other ones are on the learn.parallax.com page. All right. You may have noticed that some of the robots on day one that I talked about look kind of similar. And we do try to keep the lessons pretty consistent through all of them. The microbit has some extended lessons because it has some extra built-in stuff that the basic stamp and the Arduino do not have. But the main textbook has pretty much all the same robotic lessons for any of these three robots. So if your preference is to program in BASIC, you have the BOBot. And if you have old BOBots and you decide to switch to programming in Arduino C, you can get just the top of it and a slightly larger battery pack. And that also applies to the Cyberbot robot. You can basically take off the Cyberbot board and put on the Arduino Shield board, and then you can use the rest of the hardware that's down below with the aluminum chassis for either robot. The Arduino multi-core is a little bit different because it has feedback 360 servos, which essentially the parallax propeller is able to monitor and control in a way that allows you to travel exactly straight without any calibration, and also travel certain distances. Educator resources. If I go to learn.parallax.com, and then basically there's an educators tab across the top, and what you can do is log in. And for cybersecurity reasons, I will do that on a different screen. Okay. So once logged in, what you'll end up seeing when you go back to educators is you can find the ShieldBot educator resources. And then down here, there's some kind of general things like a standards matrix for alignments, and some suggestions on setting up your course, scope and sequence. And then the assessment materials are down here, and these will not be available until you log in. And then when you do log in, like let's say we're going to look at the Whiskers chapter, that's chapter 5, you can download the zip and then unzip it, and you'll have a folder that you can go into, and there's a PDF and a RTF. The RTF is editable in Word, and the PDF obviously would just be something for viewing. And I'll open the PDF since that's going to take less time in the machine I'm using. And so this PDF, just make sure that, so here's a worksheet that you have with matching up vocabulary terms and some fill in the blanks, and then some actual adding explanations, true or false, just lots of things that are gradable, along with some projects and solutions to questions that are in the chapter but not answered. And then the solutions are in an answer key. So if and when you're printing out for your students, make sure not to print out any of the red solved answers, because they like to distribute that kind of stuff, and we really don't want that. So again, this is some of the assessment material that's available on through learn.parallax.com. And what I'm going to do is log out now, just so that you can see what it looks like to a student if they follow the educator link, and then go to the ShieldBot. Did I overshoot it? There it is, ShieldBot. So when you scroll down and look at it as a student, you can't get to that assessment materials. there is more assessment materials available through cyber.org. Cyber.org offers curricula for teachers in the United States. And so if you are a United States teacher, you can go to sign up if you're not already getting cyber.org materials. And they will check that you are a teacher, just as we do when you try to sign up with us. And then once they give you the login credentials, you can go to log in, and then you'll see their Canvas system. And one of the points of one of the things that they make available, that they have a very wide range of topics, not just microcontrollers, which is what Parallax microcontrollers in their applications. But they have one of the tiles that you'll see when you're in their Canvas is Cyber Literacy 1 and 2. And as you can see, for Cyber Literacy 1 and 2, they have curriculum for the BoBot, for the CyberBot, and for the ShieldBot. Carnegie Mellon also has a training program. You can even potentially get a free robot from them by doing their training as well. And you may also get essentially a different take on using the ShieldBot in your classroom. So that's another resource that you can make use of. And if you need any help, we have an educator hotline. Ari, is that currently still 8 to 5 on weekdays, Pacific time?
Yes, the peak is 8 to 3, but yeah, we are covering 8 through 5, but usually 3 to 5, we don't get many calls.
Okay. So nominally 8 to 5 Pacific time. If you're stuck in your classroom with a technical problem that involves a robot, that's a reason to call. If you'd like to talk about how to implement a certain piece of hardware to meet your teaching goals, it's another reason to call. Ordering, I'd recommend calling sales, but they will also pick up often as the first line of defense on the educator hotline calls. And then if they realize, oh, this is a more in-depth question, they'll transfer you to one of us. And then there's learn@parallax.com, but most importantly, education@parallax.com. That was in the main recipient in all the emails I sent out. If you have a question, in any of the things I just mentioned, be it meeting the education goals, technical support problem, any of that, you can email education@parallax.com, and what will happen is it will get routed to either Ari, Stephanie, I, or our senior software engineer, Jeff, depending on what kind of thing it is that you need assistance with. And then we also have some forums, a Facebook page, and actually, if you go to www.parallax.com and then scroll all the way down to the bottom of the page, you'll see all of our social media here on the bottom: Facebook, Twitter, YouTube, and etc. So I certainly appreciate all of your coming today. And so thank you. And I hope you enjoyed the workshop. We will be sticking around for some after the workshop session questions and answers. So if you want to stick around and ask some questions, please do. Otherwise, we'll go ahead and stop recording. And thanks everybody for watching.